For generations, we have searched the sky for a second home, a world that could carry the weight of our survival when this one can no longer hold us. The most tantalizing candidate sits in the Alpha Centauri system, our nearest stellar neighbor. At roughly 4 light years away, it feels almost within reach on the scale of the galaxy. But the dominant force in that system is not the pair of bright stars visible from our night sky. Lurking at the cold, dim edges of the system is a third star, small, faint, and largely overlooked, Proxima Centauri. Orbiting that star is a rocky world that has captured the imagination of scientists and dreamers alike. Proxima b, a planet close to Earth's own mass, sitting within the habitable zone, the theoretical band of distance where liquid water might persist on a surface. On paper, it sounds promising. In reality, it is one of the most hostile environments imaginable. Getting there already demands the impossible. Even aboard the swiftest spacecraft humanity has ever built, the journey would consume more than 70,000 years of travel through freezing, lightless void. But suppose we arrived. What would we find? Proxima Centauri is a red dwarf, so small it barely surpasses the size of Jupiter, so dim that if it replaced our own sun, midday on Earth would feel like a deep red dusk. Red dwarfs are the most common stars in the universe, accounting for more than 70% of all stellar bodies. Their fuel burns so slowly they will continue glowing for trillions of years, far outlasting our own sun. That longevity, however, comes with consequences for anything orbiting nearby. Because a red dwarf radiates so little heat, its habitable zone is pulled in extremely close. Proxima b orbits its star at roughly 1/20th the distance Earth maintains from the Sun. A single orbit takes only 11 days. At that proximity, gravity does not simply hold the planet, it dominates it. The planet is tidally locked. One face is permanently turned toward the star, the other faces permanent night. There is no rotation, no dawn, no dusk on a global scale, only two extreme, unchanging worlds sharing a single surface. On the day side, an enormous red sun sits frozen in the sky, 3 times larger in appearance than our sun, motionless across the ages. The ground beneath it is scorched and barren. Any water that once pooled there evaporated into space long ago. Turn and walk toward the night side, and the temperature collapses into the hundreds of degrees below zero. It grows so cold that the atmosphere itself solidifies, snowing down onto a silent, lightless surface. A frozen tomb without end. Between these two extremes lies a narrow ring, the Terminator line, where the star hangs perpetually on the horizon. Some researchers once proposed this twilight band might harbor moderate temperatures suitable for life, but the violent contrast between the scalding day side and the frozen night side drives ferocious atmospheric circulation. Supersonic winds tear endlessly across that border, making the Terminator line a zone of relentless, deafening storms. And yet, the storms are not the gravest threat. Proxima Centauri is an unstable star. While our sun is relatively calm, red dwarfs are prone to sudden, violent outbursts. Without warning, the star's magnetic field snaps and releases a stellar flare, an explosion far exceeding anything our sun produces. Because Proxima b sits so close, there is no meaningful distance to soften the blow. In an instant, the sky turns from dim red to a blinding white. A wave of extreme ultraviolet and X-ray radiation strikes the surface with sterilizing force. The upper atmosphere is physically torn away and scattered into space. The ground absorbs lethal levels of energy. Any complex chemistry, any fragile foothold for biology, is dismantled at the molecular level. This is not a refuge. It is a warning. We looked to Proxima b because it was close, because it fell in the right zone, because we needed it to be something it is not. But the universe was not built around our needs. It operates on physics that are vast, indifferent, and unforgiving. What Proxima b reveals is something harder to accept than distance. We are not surrounded by near misses and almost Earths. We inhabit something genuinely rare, a stable star, a protected planet, a narrow envelope of conditions that have held steady for billions of years. Beyond this solar system, the closest shore is not welcoming. It is a world of permanent fire on one side, permanent ice on the other, and radiation raining down between. The search for another home continues, but the universe has made clear it will not make that search easy.